Welcome to this second webinar in the series of V2 Market webinars that we're doing over this winter and springtime. I'm Andrés Pinto-Bello. I'm the head of research and projects at smartEn, Smart Energy Europe. We're a business association based in Belgium, and we are also a member of the consortium of V2 Market. And I will tell you a bit more about that in a minute. But with this series, I want to of webinars, we want to underline not only the wide breadth of services that electric vehicles can provide, but we also want to highlight the critical role of electric vehicles that will be playing in the next years. This is a very relevant topic for the BeNeLux region, as you will see in a minute. This is the main topic for our conversation today, and it's mostly because of, on a big level, it is because of the increased congestion, both of caused by the connection of new decentralized energy resources, but also of a lot of renewable energies that are going to come online. So on top of that, we are, as I was mentioning, we're reaching this level of connections, or this amount of electric vehicles on our roads and cities that will dramatically increase over the next years. And this will bring significant amount of challenges for our grids and the system operators that are managing them. And this is where V2X will come in. And you can see in this slide, this is showing the daily cycle of electric vehicles and how they can behave. This, if you're not familiar with it, vehicle to X is really a combination of vehicle to grid. It's a combination of services that electric vehicles can provide to the grid through reacting to price signals that they may receive. These services, they change along the day based on the needs of the grid, but also on the consumer, making really the best use of available resources. It has significant benefits for the consumers, as you can see in this slide. And from really reduced energy bills to ensuring that we use green energy, to protecting us consumers from price spikes, and really the breadth of options is really large. And this is what the V2 Market project tried to develop, and we will see in a few moments. We wanted to showcase this potential. In this series of webinars, we will be sharing the learnings of this project over the past 3 years. If you want to catch up on our first webinar that we held a couple of weeks ago, you can join or you can check it out on our YouTube channel that we will that you can access through this QR code. And then before actually starting, just a little housekeeping. If you have any questions throughout the webinar, please put them in the questions box that you can see on the bottom right. And there's also a survey that we have to see the experience that you have and your perception of electric vehicles. You can join it through this QR code. It would be very helpful. It would be very helpful to hear your opinions and hear your feedback from wherever you're coming from. So a bit about the project V2 Market. We started in 2021, and the goal of the project was really to increase the adoption of electric vehicles by creating the favorable market conditions, and to provide the right incentives for electric vehicles to provide services to the grid, services to buildings, and services to consumers at the end of the day. And how did we want to do this? First, we want to tackle, everybody, you will see in the next slide, We have to include all the relevant actors in the EV value chain, from the providers of the technologies to the users of the flexibility, to the let's say the suppliers that might be interacting with the consumer directly, the independent aggregator that is involved, and of course the users, the system operators, and so on. All the cities, the municipalities in this case, as you will see in a moment. But for that, we also needed to tackle the financial barriers that we could face by the creation of these new services. And for that, we looked into different options. We looked at the servitization model for integration of V2G. We will hear a bit more about that later on. And also the energy performance contract integration for vehicle to building services. We, of course, also needed to be aware of what are the regulatory challenges that we might face to implement these kinds of business models, and we will see a bit from that from my side later on the more European level, and we will have a presenter showing us the concrete topic of today, which is the BeNeLux region and how the regulation plays out there. So the market, the project passed through different phases. I already highlighted a few. The market analysis, really knowing what is going on electric vehicles. The business case design, so really understanding what is the value proposition that we identified for the different profiles of users. So yeah, from public, private users, households, municipalities, and so on. This varies, and also depending on the use of the car that you will have. Then we wanted to test it, of course. And this we're doing both in, we have two different test sites or test pilots. One is where we're testing V2X, so a vehicle to grid with 12 bidirectional chargers installed and in the municipality of Barcelona, in the buildings of the municipality of Barcelona. And we've also tested this with Elaad, one of the Spanish suppliers that are involved with residential consumers that will be using electric vehicles. And then in the exploitation part is really to create, how do we facilitate the learnings that we have had over these past 3 years for the wider consumer base. So we're going to be releasing a standardized contractual guidelines between EV owners and aggregators. We're going to create materials to train potential electric vehicle users and to really spread the word on EVs, on V2X, and the potential that they bring to the table. Now, just very briefly, these are the partners that were involved or that are involved in this project. So you can see we have from the whole value chain of V2X services represented in the proposal, and not in the proposal, in the project, and this is really the whole partnership that we have. Now, I wanted to highlight very briefly one of the next upcoming milestones of the project, because this is very relevant, also taking into consideration some of the speakers today, because this platform is what we're testing now virtually, because it's not yet allowed by regulation, where we're testing the use of flexibility in the metropolitan area of Barcelona. We're using OMIE. This is one of the Spanish partners that provides a local markets solution to the project. So we're testing in this platform the use of the electric vehicle fleet and how they can provide congestion management services to the distribution network of Barcelona. This is very brief highlight of this next milestone. We will be talking about this at a later stage, but it's already something to take into consideration. So now into the framework that allows electric vehicles to thrive, and that is the regulation, the European regulation. So so first of all, we have already electricity market directive and regulation that sets the scene of the use of electric vehicles and other distributed resources in different markets. But it needs to be implemented, and this is where we're still lagging behind. There's a significantly slow implementation of the electricity market design. And this is a map that we see on the screen. This is a map from a publication that we had actually just launched, the Market Monitor for Demand-Side Flexibility, together with LCP Delta. This is a publication that highlights what is possible for demand-side flexibility in different European markets, from system operator markets, so TSO and DSO markets, to capacity markets and wholesale markets. But there are significant barriers that are limiting the development for vehicle-to-grid and vehicle-to-building services. It is true that actually BeNeLux region is one of the best performing, as you can see in this map. So we take this as a good win. We will see this in a moment with one of the presentations. But there's still a lot of work to do, because electric vehicles, you cannot develop a solution for an electric vehicle just for one member state or two member states. So really we need these rules to be applicable or harmonized across Europe, because we need to ensure that they have access, all consumers have access, all vehicles have access to the same kinds of services across EU member states. So how can we achieve this? There's two steps. I would say, as I mentioned, all of this is already in European legislation. The first step is really allowing aggregators, the figure of an independent aggregator that will pool different resources like electric vehicles into large enough resource that they can have an impact on different markets. So first, there's, let's say, 3 articles that are quite important to achieve this. So the first one is Article 17 of the Electricity Market Design. It really creates the framework for independent aggregators, and without that figure, we cannot really do much in different markets. It sets the roles and responsibilities that they might have, and make sure that demand response can participate without discrimination into any markets. And then we have 2 other articles, the Article 13 and 15, that really empower consumers, active consumers, to take a role and to participate in different markets. The second step is ensuring that there's market-based procurement of demand-side flexibility by system operators. And here you see the first box again, Article 17 of the Market Directive. This is not a mistake. This is on purpose. This article is very important. And without the correct implementation, we will not have the empowerment of consumers, and we will also not have the access to markets for these resources. So really an important article to implement. Then we have Article 6 and 22 of the market regulation that ensure that whatever products are procured by system operators, so local congestion, ancillary services, whatever product they are procuring, it is done so on a technology neutral and on a market-based manner. And technology neutrality is very important here, because it is very easy to build in requirements into the product design that de facto excludes sources like electric vehicles, because of the capabilities that they have, because of their small size. It is very easy to build in, for example, minimum bid sizes that are way too high, that might be that might be excluding these resources. And then finally, Article 32, and this is really important, we need to provide system operators the incentives to procure these services. So system operators, until now, they have had incentives to invest in grid reinforcement. This has been their main activity over, historically. But now we have to also provide this incentive in regulation. Well, regulation already allows this through Article 32, but we need to implement this in national legislation to allow them to recuperate the costs from using services like demand-side flexibility as an alternative to more grid reinforcement, to more investments in copper. Okay. So these are the two steps. We will see in a moment now how this has been implemented in Belgium and what are the effects of this in Belgium, sorry, in the BeNeLux region. But just a little word on what are the next steps beyond these first two initial ones is that we do really need harmonization, not only in product design, but also in data exchanges. And you see here a selection of data standards that we have, that we're proposing. And this is really an integral part to exploit the results of a project like this, like V2Market, on a European scale, because we need electric vehicles that have the appropriate standards to communicate with the houses, with the system operators, with flexibility service providers, seamlessly and out of the box, because one of the key aspects here is that we cannot overcomplicate this for consumers, because otherwise they will just not do it. I will not go into the individual standards because I'm already taking a lot of time on this, but this is, let's say, the next frontier of to facilitate the expansion of V2X and V2B across Europe. This is it from my side. I'm going to now invite over on the floor Jack Thomas. He's the senior consultant at DNV, and DNV prepared a study on V2X and electric vehicles and the impact and the regulatory framework across Europe. And he will be telling us a bit about his learnings or their learnings on the BeNeLux region. Jack, the floor is yours.
Thank you very much, Andrés. Let me just share my slides. Okay, so yeah, as Andrés said, I'm Jack Thomas. I'm a senior consultant in DNV's Energy Strategy Advisory, and we are a set of independent energy experts that help our customers navigate the complexities of the energy transition. And as Andrés said, over the last over 6 months in 2023, we assessed the regulatory frameworks for bidirectional charging across 11 different European countries, and have sampled a few of our results for Netherlands and Belgium to kind of facilitate and add to this discussion today. So just a bit of background on the study itself. The objectives were to assess the level of maturity across Europe for bidirectional charging from a regulatory framework perspective. So we looked at topics like the levels of EV rollouts and charger availability as a proxy for V2X, which, as we know, across Europe has not necessarily been installed or deployed at a wide scale. We also looked at the regulations and the access to different markets across the different countries that were studied, as well as relevant national standards and DSO requirements. So I think Andrés has kind of emphasized the importance of bidirectional charging moving forward. DMV also contributed to a study for smartEn that quantified the benefits of bidirectional charging to the EU going forward, and demonstrated the kind of significant benefits that it could bring, and therefore reinforcing the need for a regulatory framework that promotes and incentivizes bidirectional charging in the future. So in terms of how we looked at each country, we looked across a number of different topics. So EV and charging development considerations, regulatory, and then the final aspect was around commercialization streams. So what revenue opportunities are available to V2X within the different countries assessed. So we looked, we kind of collected qualitative data, interviewed some technical experts from different countries around Europe, and that fed into our assessment of the level of maturity of that country across the different topics that we explored. Some criteria were given slightly greater weighting based on our kind of expert assessment of each of the criteria that we looked at. And then we scored each country red, amber, green based on the level of maturity. So to focus in on the Netherlands, in terms of its EV and charging development, so it has a higher than average share of new battery electric vehicle sales, and also existing charger infrastructure. It also has a higher than EU average ambition for its future charging infrastructure going forward. There are also credit mechanisms and guarantees of origin schemes that provide trust and transparency in the energy that's used through and by V2X. From a regulatory perspective, as the majority of countries across the EU, there are no specific V2X or bidirectional charging policies in place in the Netherlands. There are, however, as there is across Europe, pilot projects and incentives available for those pilot projects, which have reached the kind of millions of euros within the Netherlands. And then the other aspect we approached from a regulatory point of view was looking at taxation. And although double taxation of intermediately stored energy is addressed with the netting of taxes for V2G, that netting of metering is being phased out in the future. Therefore, kind of a new way of approaching that needs to be found moving forward. In terms of revenue streams, there is a high smart meter penetration. However, despite this, Dutch households pay 95% of Dutch households pay the same or on the same tariff, and therefore there is limited kind of incentive for implicit flexibility for grid purposes. There are DSO local flexibility markets where they procure market-based congestion management. However, participation in these markets is relatively nascent and developing. And then also in terms of access to markets, V2G can participate in wholesale energy markets within a portfolio of energy suppliers. So then to contrast with the Netherlands, from a Belgian perspective, we see a lower than EU average share of new electric vehicle sales and charger rollout, as well as the kind of lower than average goals for charging stations. As with the Netherlands, there is kind of guarantees of origin that provide this trust and transparency in the energy that's used. And then from a regulatory perspective, it's kind of a similar case where there are no specific V2X policies in place. There are ongoing trials and support for those trials. However, there is double taxation of intermediately stored energy, which we know is a potential large barrier for energy storage going forward. From a revenue stream perspective, there is low smart meter penetration, and while there are time of use tariffs, these are generally day and night tariffs or a flat rate. DSOs are not currently performing market-based procurement, although there are plans to develop this. And while V2G can, in theory, participate explicitly in wholesale energy markets, there is no kind of publicly available information of this happening outside of ongoing trials. So then we've tried to pull out some kind of common challenges and barriers that are observed across the BeNeLux region. So as I mentioned, there are kind of complexities and inconsistencies surrounding how intermediately stored energy is taxed. This affects the business case for V2X through kind of increasing the levels of uncertainty and also affecting the bottom line in terms of acting as an additional cost to the operation of V2X. There is also inconsistent access to markets, and with the value of flexibility changing throughout a month or a year, it's important for there to be a kind of a diverse range of revenue opportunities that V2X can access, so that they can kind of vary which markets they target at any given time. What we also found is that there are burdensome requirements from a metering perspective from the measuring instrument device regulations across Europe, not just specific to Belgium and the Netherlands, where there are kind of onerous requirements around the requirements for a digital display on charging equipment and restrictions on over-the-air updates, hardware updates, that are acting as a barrier to those charges being used for metering purposes. There is also a lack of developed, in the case of Netherlands, or even existence of commercially operational flexibility markets at a distribution level. And then finally, specific to the Netherlands and Belgium, there are certain restrictions from grid operators on the maximum injecting power that can be injected by a V2X charger, as well as restrictions on which inverters you can connect to the grid, and these are determined by the requirements for generators, kind of requirements for inverters going forward, and these are potentially acting as barriers to the connection of new V2X chargers going forward. So those are the challenges, and what can we do about them? So within our report last year, we recommended a kind of a collection of different options and recommendations going forward that can address some of these challenges. Most significantly, or highly significant one related to lots of different countries around Europe, is the removing of double taxation of stored energy, as well as the standardization of the treatment of the energy that's lost during the energy storage cycle as batteries charge and discharge. As Andrés kind of emphasized in his presentation, there's also a strong need to implement existing EU legislation that will underpin the deployment of V2X going forward. So that's from the perspective of introducing electricity pricing that stimulates grid-friendly behaviors, that allows for access to that range of diverse markets across wholesale energy and balancing, as well as establishing distribution, local flexibility markets, and also incentivizing the rollout of smart meters. Another thing that member states can do is mandate bidirectional charging in certain areas that they have the most control over. So whether that's public fleets with long duration parking, or buildings with renewables to incentivize and maximize the use of or optimize the use of the self-consumption of renewable energy. And then finally, we emphasize the importance of that V2X should have the same access to different support mechanisms that other energy, distributed energy sources can access, as well as generators. So this includes capacity remuneration schemes and also specific tendering subsidies such as flexibility support schemes. So that concludes our kind of quick summary of the Belgium and Netherlands regions. And yeah, interested to hear if anyone has any comments or queries in the Q&A. Thank you very much.
Thank you, Jack, for this in-depth vision into the Netherlands, Belgium, and Luxembourg. I want to remind everybody, if there's any questions, please leave them at the question box. We will be answering them later when all of our speakers will join us in the stage. But next, I will have Csaba, the Csiky. He's the chairman and senior partner at EnerSave Capital, one of our partners at the V2 Market project. And he will be talking about the servitization model. A very innovative solution that we try to introduce for electric vehicles. And I will let Csaba explain this a bit more. The floor is yours.
Thank you very much, Andrés. I think that we can skip my first slide because Andrés very well explained what V2M is all about. Sitting in Luxembourg, I'm an investment banker. Have been doing this for many, many years. Some say for too long. But this whole energy transition is a very, very fascinating subject, and we are delighted of being part of V2 Market consortium. Now, I'm stating the obvious. We all know it. Cost of EVs is one of the key issues. Are there going to be subsidies? Yes, no. When do I buy? I've seen it in Luxembourg. It's the politicians are changing very often their opinion. But then we are getting into the practical side, range anxiety. People think that this is all too complicated and we will never get where we want to. Whilst at the same time, the average range, which is driven in a day, is 50 kilometers, so there should be no worry about that. One of the big issues for the financing community is actually the higher residual or the lower residual value, which we have very well analyzed in V2 Market project. So this is an issue, and leasing companies will need to deal with that. Which means that they are going to be charging higher rates so that the higher amortization can be taken care of. Finally, the used car market is a big issue because whilst when I was younger and trying to be very clever, I was able to, or was hoping to be able to assess the status of the engine of a petrol-driven car by looking at the oil stick and everything. Well, in the battery, it's very, very different. And it's a big black box for many people. They don't know what is happening in there. And we all know what happens when we don't know what's happening. Well, we don't like it. Could I please have the next slide? What we have seen in the used car market, and part of the knowledge I'm sharing here with you comes out of the Green Finance Institute's very well written report on the used car market as well. So I mentioned the incertitude of the battery state, and that is a big issue for the buyers of the EVs, especially when the car is out of warranty. And sooner or later, that happens. 5 years is not a long period. General leasing is between 3 and 4 years. So people are starting to be very uncomfortable about how much battery capacity they're actually buying. I was speaking about the residual value, and whilst according to the Green Finance Institute, leasing companies are generally comfortable in financing the used car sector. It's actually the demand which is lacking from the used car buyers. And this is a big holding back in the whole value chain and in the whole financing. And actually financing is what made the car industry as big as it is. Nobody is having 50,000, 70,000, 100,000 euros lying around, or those who have it lying around to buy an EV very often go for a leased solution because it's all inclusive, it's no headache. And when one feels that 5 years or 3 years down the line, when the contract comes up for renewal, one just gets a new vehicle. So practicality is very, very important for the EV participants. Could I have the next slide, please? Now, we need in the whole energy transition to come up with new business models. And the more we are speaking about this whole thing, the more the focus is the battery. The car itself, it's having less moving parts, is a cheaper proposition. Electric engines are very easy to maintain, but the cost of the battery, that's the big one. Now, if one would be able to exclude the battery, not technically, but legally, from the proposition which one is giving to the end client, suddenly the whole proposition would come down by at least 1/3. And as the car industry is moving to more and more as a service, you can buy today, when you buy a Mercedes, there is a massage function already installed. It's just not activated because somebody said that when buying the car, the buyer said, well, I don't need that. Suddenly he hears from somebody else that the massage function in the car is very good, and particularly when you're standing in congestion, you say, well, why can't I get a little massage? You can call Mercedes-Benz, BMW, and all the other ones. And for a small amount, they're going to open this function. So as a subscription on a subscription basis has already entered the car industry. So why not have battery on a subscription on a unit cost basis, everything provided in one price? This in turn would help the battery owner to exploit the battery via V2G services. I was involved in a project valuation, and we saw that Fiat actually every day is having 1,000 EVs plugged in, and it is being paid grid services by actually the paint is drying. So at the Mia Flore factory outside of Torino, you must imagine there's an enormous parking lot, and all of those cars for 10 days stand there and provide their services to the grid. Already one way of reducing the ultimate costs. Now, if the battery is excluded, then the aggregator of the battery is able to access the capital markets and finance himself from there, whilst the client would be still going to his leasing company, who based on his credit rating would provide him with a lease. But as the car is much cheaper and the battery unknown is excluded, probably the leasing terms would be better, which then would make the acceptability by the EV owner much easier. As soon as the car is handed back, the EV finds itself on the court of the used car dealer, and while it's standing there, the battery again can provide its services until it finds a new home. So the ability of permanently generating revenues is what is essential to the grid, because to wait for the grid not only to be financed, to be implemented, and particularly for the whole process of permitting is a very, very long time. So we need solutions very quickly. Finally, if the battery would develop a fault, this can be analyzed from the distance. The battery owner would change the battery and use the battery in second, third life applications. And finally, the battery gets ground down and becomes raw material for a new battery. So if one can balance, or if the aggregator can balance the various revenue streams, most likely we will be able to come up with a cheaper proposition. But all of that only makes sense if an aggregator can have 100,000 batteries, because for one battery it doesn't make sense. Could I have the next slide, please? So the servitization model, as I hinted at, has been around. You can buy various things. Probably your software is on a monthly subscription. You get your mobility as a service, a lease plan, or today Leasy is providing this very well. Schneider Electric is doing it on a kilowatt basis. You can have lighting on a service. The Philips daughter Signify is doing that. We do cooling on a service. We do heating on a service. And it's a business model which is very well accepted, and investors understand it. And we must never forget that it's the investor appetite for this kind of product which is out there, which is a key driver for being able to move the energy transition. Could I have the next slide, please? So how does servitization happen? What would it be? The household would own the vehicle and would have battery as a service provided on a kilometer fully charged basis. You actually pay for what you use. You would probably say that when you are contracting for the battery usage, that on a day-to-day basis, I would need 50 kilometers. And on the weekend, as I go and see grandma, I would need 100. And in 1 month during the year, I will not be able to be part of this whole scheme, because I'm going on holiday, and there I don't know what kind of charging infrastructure I'm having. And here clearly the regulation is very, very important. One would include a bidirectional charger, battery replacement, as I hinted earlier, and off we go. So by having two different business models, without the consumer actually noticing it, in the worst case, he notices it because he's having two invoices. In the best case, the leasing company would include the payment in their own costs. Could I have the next slide, please? Now, battery as a service would help in all kinds of business scenarios. It would be the same for a municipality, where clearly the cost of acquisition would be reduced, but as well as large fleet operators and for individual households. And clearly, Andrés very well hinted at the model of Olaluz, where actually the battery or the vehicle is acting as a big buffer. So benefits, I mentioned lower capex, predictability of cost, carefree, particularly important once the warranty is gone. You can via an app dictate or indicate how much range you would be needing over a certain day. You can always increase the range which you are needing, meaning a reduction in the flexibility which the battery owner would have. But if we can heat our homes via our mobile phone, then it's an easy solution to adjust the range to the consumer's need, and the consumer's needs are on the forefront of everything. As one integrates the older batteries throughout their lifespan, one is able to really support the energy transition with storage in second life storage, or at hospitals where today there are big battery banks of lead batteries waiting to support if there is a grid outage. Could I have the next slide, please? So how does a servitization contract work? There's an aggregator which will own the battery, will own the directional charges and put them at the disposition of the household. The aggregator sells the output of the battery for a predetermined price and amount to the vehicle owner. He's responsible for maintaining and ensuring that everything works. And the great thing in servitization is that there's a complete alignment of payment, of interest. If the battery owner does not provide the range, the client does not need to pay. The flip side of that is if the client doesn't pay, the owner of the battery can very quickly reduce his service, and that clearly, and we see it from other financing models, keeps the relationship very, very honest, which in turn reduces default events, and reduced amount of default events reduce interest rates. So it's a win-win for everybody. Could I have next slide, please? And this brings me to the end. I will leave the questions to the end, and I'm looking forward to answering them.
Thanks a lot, Csaba. Very interesting proposition, a new business model, but not so new because this is already happening elsewhere. So an important lesson to take away. Next, we will have Baerte Brey. He's the Chief International Officer at Elaad. And he will be talking about the bidirectional charging integration in low voltage networks in the Netherlands. Bart, the floor is yours.
Hi. Yeah, sorry, I was muted by the organizer. Let me see, I'll share my screen, or do you have my slides available? Yeah, there it is. Perfect. Well, my name is Baerte Brey. I work at Elaad, which is a collaboration of Dutch grid operators. And what we try to do is integrate e-mobility into the energy system. As you can see here, e-mobility is a huge challenge and opportunity, but also other things are happening. Large-scale wind generation. Next slide, please. Yeah, but also here is what's happening in the Netherlands, electric vehicles, but in the background you see a house with rooftop solar. And previous people mentioned what you don't see is a heat pump, for example, inside the house to heat your house. And this is about the BeNeLux. but in Southern Europe, there probably will be an air conditioning as well, consuming energy. Next slide, please. And of course, this creates some peaks on our grids. Demand peaks for just household appliances. That's the blue wave. People getting home at 5 o'clock in the afternoon, doing their laundry, cooking, charging phones, whatever. And in the morning, of course, heating the house or turning the air conditioning on. And at the moment, due to the energy crisis, we also see a huge peak on the grids, a supply peak, so not a demand peak, but a supply peak generated by rooftop solar. Keep in mind, at the moment in the Netherlands, where we are a Nordic country with dark winters, but 50% of owned houses, so people who bought the house, already have rooftop solar installed. 30% in the city of Utrecht of the rented houses have rooftop solar. And due to existing regulation, which was not terminated as we expected, but it is lengthened for the coming year, there is a incentive for netting. So you can the energy you produce during the summer, you can add that to the energy you consume in the winter, which is very beneficial for people with rooftop solar. But for grid operators, this is really causing an issue. And one of the solutions, next slide please, is of course the battery of the electric vehicle. However, electric vehicles cause a demand peak. Next slide please. What you here see is replication of a distribution transformer and some cables with houses on it. And the average household in the Netherlands consumes roughly 1 kilowatt. Adding electric vehicles, next slide please, you add 10 kilowatts, 11 kilowatts on a curbside charger. The majority of people in the Netherlands don't have their own driveway. They're charging by a public charger, mostly AC, which is 10, 11 kilowatts. But you add a lot of extra consumption by just some vehicles, not 100% of vehicles in the household or in the neighborhood. But this gives an idea of all the added consumption demand on the grids. Next slide, please. And this is causing congestion. At the moment, this is a chart of the grids, the TSO grids, the high voltage grid, the mid voltage grids being fully congested, both by supply, wind, solar energy, but also by demand, by electric vehicles, but also data centers. And of course, well, this is an issue, but it also is a signal that we're on the right track, because the bigger goal is electrifying society, because we're challenging the global heating. And this is everything. Electric vehicles don't emit small particles. They don't have a combustion engine, and solar generation is of course better than heating your house with gas or coal-fired energy. So yes, we have issues, but it's also a signal that we're on the right track in the Netherlands. Next slide, please. And to solve this congestion, of course, the traditional solution is investing in the grid. Expensive and causing a lot of hassle. Open streets. Next slide, please. And of course, this you can study the details here, but it takes a very long time. Top left, high voltage transformer station is really millions. costs millions. So it's not only the cabling, but also the stations has to be reinforced, and it takes on average 7 to 10 years. Next slide, please. And this is also the same, not as long as high voltage stations, but this is a cascade of high voltage, mid voltage stations to low voltage stations. So we need massive investments in the grid. Next slide, please. And it takes a long time. But also alternatives are welcome, are needed, because we don't have the time, we don't have the money to do it the traditional way. Good signal is 100,000 consumers with dynamic energy contracts just showed the proper behavior. They started to charge their electric vehicles on times when prices were low. It's common sense, but the data shows it. That with smart metering installed and awareness of consumers, well, a lot of the issues can be solved by just adding smart charging. People charge their vehicle when it's either windy or there's a lot of capacity at night on the grid and prices are low, or of course during the day when there's a lot of solar generated. Next slide, please. But that only solves a part of the deal, because on a sunny weekend, or if you're on a summer holiday, your car is charged and then it's full. So what we did at Elaad and with the grid operator Steden, we calculated what are the investments needed in Utrecht if we do nothing. On the left, well, we have to invest in roughly 25% of our assets to upgrade them, to give more capacity. With adding traditional charging, just plugging in at 5 o'clock and start charging, we have to double that investment. And static smart charging, so don't charge at say 5 o'clock till 7 o'clock in the evening, or do charge at night. It solves a little bit, but you still need investments in distribution transformers. With dynamic smart charging, keeping in mind when it's very sunny on a specific day, maybe in the afternoon at 5 o'clock, you have a supply peak, but the static pattern doesn't allow you to charge. Dynamic charging solves roughly 5%. But the holy grail is really vehicle to grid, because then if there's a demand peak by air conditioning or heat pumps, then you can discharge as well. And you can you have much more flexibility, not only one day in a weekend and then you have a full battery, but you can do the play again and again with charging, discharging when it's sunny. Next slide, please. So Utrecht, the city I mentioned, with a lot of rooftop solar, but also a very high ambition target for greenhouse emission gases, reduction of them, deployed a strategy of being the first city in the world with a bidirectional charging network, solving the issue. The vehicles aren't there because the chargers aren't there. Well, this is a news item of 5 years ago, 2019, 145 public chargers. And it isn't in the news anymore, but last October, so 2023, the municipality did a tender for 2,500 bidirectional chargers, and they're installing them now. That was won by Total Energies. Next slide, please. And this is not only doing the tender and saying to Total where just to install them, but together with the grid operator Steden, we developed an energy planning tool to see where are the future EV drivers, where are car sharing companies with bidirectional vehicles in their fleet needing to charge, but also where do we have an issue with the grid. So we developed an energy planning tool combining demographic data with cabling data and plans of the municipality regarding mobility and parking availability. Next slide, please. And then, of course, we saw the vehicles coming. Utrecht isn't an island on itself, but we're collaborating in a scale project, horizon project funded by the European Commission with Polestar, Hyundai, Renault, on developing electric vehicles that can do bidirectional charging, with sister use cases in Göteborg, Oslo, Munich, Paris, Budapest, and Greece. And of course, at the bottom right, you see our king driving one of the first bidirectional Zoes. Renault just announced that by the end of this year, they're introducing the Renault 5, a follow-up version of the Renault Zoe, being fully able to do bidirectional charging based on OCPP and 1511.8-20. Hyundai Ioniq is also already on the market. But also, it's not only successes that I would like to preach. Many hurdles have to be overcome. Andrés mentioned one in regulation. At the moment, we're studying them, and together with PwC, we'll launch a report just prior to the elections of the European Parliament to give the new candidates some homework, what they can improve in the coming 5 years. So we re-identified the regulatory barriers for smart charging. But it's also a business model. Unfortunately, on the top left, there's a Sono, a very nice vehicle with integrated solar panels in the vehicle. But it won't come to the market because, well, also technique and finances have to come together. And they unfortunately went bankrupt during our project. So keep in mind, it's not an off-the-shelf project yet. Economic barriers, technical barriers, such as standardization, new versions of the protocols have to be solved the coming years. Regulation has to be set, but we get a new Parliament, European Parliament, and Commission, so we can push a little bit for their involvement as well. Next slide. And that's the thank you. Looking forward to your questions. Over to you. Thanks.
Thanks, Bart. Very interesting. And now we're going to see, after seeing the local perspective or the DSO perspective of the Netherlands, we're going to hear from Hugo Niesing. He's the responsible for the EV charging energy strategy at the Municipality of Amsterdam. So we're going to go even more local. Hugo, the floor is yours.
Thank you very much, Andrés. Hi, Baerte. I think I need to go fast through some slides because you already said it. I'm going to try to share my screen. Is that working?
We cannot see it yet.
Yeah, I have to click on an allow button. Is it working?
Yeah, maybe people have to close my screen.
I think it's loading. There we go.
Yep.
Now it is.
Okay. Well, good afternoon, everybody. My name is Hugo Niesing. I'm working at Resourcefully, company specialized in the transition of buildings and cities towards a more sustainable model, including heating, mobility, solar generation, etc., etc. On behalf of the city of Amsterdam, I'm working on a couple of very relevant projects regarding the transition, of which I will explain two. But first, let me dive into Amsterdam's ambitions and where we stand now. So I'll give a brief overview of the consequences of the transition that we are fully into. Then I will explain the impact that we suffer at this moment in Amsterdam regarding our electricity grid, as Baerte was already mentioning. And I'll show two projects. One is in a piloting stage, and the other we are upgrading to all public chargers in the city of Amsterdam. So we have firm ambitions to reduce our emissions, both for local and for global quality of our environment. The heating is supposed to be without any gas in 2040. We would like to have all mobility without emissions in 2030. And there are also very high ambitions on solar and wind. Regarding solar, the Netherlands is the world champion of amount of solar per person. We do it better than Australia. It's very interesting to see how a country with so much gray days is doing so well, but that's all because of policies. And now we need to use that solar as good and as flexible as possible. So during the beginning of the last decade, Amsterdam really has invested a lot in the city charging infrastructure because we were facing a chicken egg problem. People were not buying EVs because there was no charging infrastructure, and there was no charging infrastructure because there was no demand. The city promoted financially, but also by services, the buying and the charging of EVs in the street. If you were buying an EV, within 3 months, you have your own charging point within walking distance of your house in order to comfort this transition. That has worked quite well. We have really a steep increase in the amount of charging stations. At this moment, we are above 5,000, 8,000 charging point. I'm putting here 7,580, but that is of 2 months ago. And also the amount of electricity demanded is going steep up. And the amount of charging is not such a big thing. It is mainly the moment when it's charged. In 2030, we would like to have 18,000 public charging points, but 50,000 private, and about 13 inside houses, so by companies, by the people at home, and in the public domain. All have their ambitions, and in all of them, the city has a different role. I will now focus on the charging in the public domain, and later also in the house owners or in the parking garages of buildings. But first, we see a steep increase in the peak demand at the same time in the whole city. So, as I said earlier, the problem in Amsterdam and in the province is not the amount of electricity that we require, but the moment that we require it. But I'll get back to that later. Here we see the image of Amsterdam. The above, the red zone, is completely under congestion for the middle voltage. That means that the DSO is not allowing any connection bigger than 3 times 80 amps, and that affects not individual households. It does not affect the individual charging stations, but it affects buildings, schools, any company who would like to electrify their fleet, etc., etc. So it's really a big problem in reaching the ambitions of the city, because this congestion period might last until 2030. Now, if you look to the map of Amsterdam, here we see these are 8 different zones, and each zone has its own characteristics, because grid congestion is not occurring 24/7, 365 days a year. So after talking a lot, the DSO provided us with data on when in a certain area congestion occurs. And we're now going to look to this part where I hope you can see my mouse. This is the Vliegenbos area, which is Amsterdam northeast. So here we see the same area. The actual power is 37 megavolt amperes, and in 2026 it will be enforced with another 26. Now, for now, we received from the DSO this information. The yellow part is a 0 to 5% higher demand than the maximum capacity of this station, this Vliegenbos station, serving about 40 to 50,000 inhabitants. And what we conclude is that April, May, June, July, August, September, and October, we do not have any congestion. It is merely occurring December, January, February, a little bit November, a little bit in March. And at the left side, you can see that it is basically only happening between 4 in the afternoon and 8 in the evening. So how can we try to deal with the DSO that we make use of the available moments and that we reduce the amount of electricity demanded at those periods in the winter between 4 and 8? And then in this area, the answer is smart charging. And I 100% agree with Baerte that vehicle to grid is the next level on top of smart charging. But that is still waiting for standardization, communication protocols, cars adopting it, and they are also the business case. As Bart already said, a car can take the peak amount of 10 households, and unfortunately, people are coming home, putting their lights on, cooking electric, and they plug in their car. So the car is, for a huge amount, contributing to this peak demand between 4 and 8. And at the station that I was showing before, this Vliegenbos, we did an investigation because this area is highly residential. There is almost no industry, there's no logistics. And on top of that, the people there do not have their parking places in garages. Almost all cars are parking in the streets. And that has an advantage because the parking in the street is done by a CPO controlled by the city of Amsterdam and the DSO. And that's what we experimented together with the DSO, together with Elaad, together with the CPO, and together with the University of Applied Sciences of Amsterdam in the Flex Power project. We looked at 10 different places, these small areas that you see here, and all of them had about 6 to 8 charging stations, meaning 12 to 16 charging points under this small transformation house. And we studied the behavior, so the time of connection, the amount of electricity required, and the time that the car was really charging, how much it is charging, when it stopped charging and was idle connected. And that gave us a lot of insight because the simultaneous charging 3-phase 11 kilowatt almost did not occur. One car was only using one phase because it's a hybrid. The other car stopped after charging after an hour because it only required a little amount. And we could reduce by half the amount of electricity available or let's say reserved by the DSO, and 1% of the cars was affected in the fact that it had to charge half an hour longer. And that was not a problem at all. So 99% of the charging sessions were executed as if all power was available. And then we started to play around. What happened if we reduce 50% of the power? Well, that's what I explained. 1.1 was affected. But if we would go down to 6 kilowatts, so we come from 16, we go to 8 or to 6 or to 2.5. Well, by 2.5, 50% of the charging sessions have an impact, meaning or the battery is not fully full, or it had to take longer to get the car fully loaded. But especially in these residential areas, 90% of the electric vehicles are present 12, 14 hours, and they don't need to be charged in that peak moment. And now we are in a phase where we are going to upscale this, and I will go back to this Vliegenbos area. And the good thing is that in the public space, we have the Municipality of Amsterdam. We make the contractual requirements. Equans has won it, and Leander participate. And together we give a day ahead, for every 15 minutes, the amount of electricity that the CPO can distribute over the group of cars under the transformation house. And that gives us a lot of power to steer the demand of electricity to the desired moments. And here we go back to the area of Vliegenbos. We see here the total amount of energy demanded in 2030. And on the upside, it is in the winter. And the upside, we do not change anything. We just see the growth of the amount of public chargers between now and 2030. And in the flexible case below, all EV charging sessions in the public space and in the domain at home are moved post 8 o'clock. So this yellow bubble, what you see here, and the red line is accumulation of everything here between 4 o'clock in the afternoon until 8 in the evening, all postponed later in the evening and over the night until the early morning. And this is giving a space of about 12 megawatt reduction in peak demand. You see here it's at 37, 38 megawatt, and here it is at 25. And we know that this is not realistic, but we will definitely reach 50% of that, and maybe even 2/3, because we control the public EV chargers, and thereby we can take care that these extreme peaks are avoided. And at this moment, we are going from 400 to 5,000, and the 5,000 charging points being controlled are going to be ready after Q2 24. So in August, all EV chargers taken over by Equans will be up and running. And the main challenges is to know very well at the lowest level of the grid how the energy fluxes are occurring. And the other one is acceptance, or are we going to allow a opt-out option? An opt-out option can be provided, meaning that you don't want to participate because you only go for a short while having dinner with your friends, and after 2 hours you want to go away with the expected 20 kilowatt hours. Another way is to tell and to educate that if people have short visit and they need to make a significant drive afterwards, pass by a fast charging station and take care that you have enough electricity. That is a political debate which is up and running, and also part of the national agenda, where the Flex Power project also has been an important standing example. And we really would like to avoid that every city or every region is doing its own way of smart charging. And at national level, the objective is to have 60% of all public charging sessions smartly integrated into the energy system by the end of 25. That's going to be a big challenge. So during the Flex Power project, we had very little complaints, and we've seen that we can increase the amount of charging poles incredible without having to reserve extra electricity. And this is really a very big step ahead. And during this year, we will have them of the biggest TPO, all of them will be up and running and flexible charging. But one of these, the 10 pilots where we were executing flex power was an island where only 35% of the parking is occurring in the street. 65% of the public parking is occurring in the carports or in the parking garages below the buildings. And it's this area in the Eastern Harbor. I'm living myself in Eastern Harbor area. It's a former harbor. I live on a houseboat in a former harbor. That's very nice. But it is a challenge because we cannot, as a city or as a grid operator, do anything obligatory on how people behave at their houses with their charging equipment or with their heat pump. And this is the title. These 10 transformation houses that we see here, these are the one being measured. The rest are being modeled, and we really need to improve the modeling to make it as adequate as possible to do actually smart steering. Now, from the 2,300 of those transformation houses, 1,000 almost need to be increased in capacity. The cost is 400K individually. So the total operation will be 300 to 400 million. And we do not have the time, we do not have the materials, we do not have the space in order to do this. So what are we looking at? We look to what can we do by intelligence, smart charging. We really look to convince and to create awareness that people consume their energy for their electric vehicles at the right moment. But also in this island, there is a lot of solar. They make 50% of all the electricity themselves. So also related to the first speaker, we are now going to make an energy community, which is not only creating more than 50% of the electricity they need, but also consuming it. And we would like to formalize that so that the most important energy provider is the community, not the individual contract that you have with a Vattenfall, a E.ON, or another big energy provider. And we want to show how this contributes to the reduction of emission of this neighborhood. We did a research with the University of Amsterdam, and we showed that only by smart charging in the EVs, we can decrease for a third the peak consumption in 2030, avoiding burning transformation houses, as you see on the left, but getting into the green zone. And that means that this same transformation house does not need to be upgraded or an extra place near 28 to 2030. No, it can live for more than 15 years. How are we doing that? Well, this is the same area. It's being measured by the DSO. We know exactly how these 8 charging poles, 16 stations are functioning. We know about the last 10 years how and where solar is placed. And we developed an energy monitoring system. Now, this energy monitoring system works quite adequate. And here in the example, you see it. This is the 1st of September. Between 1 March and 1 November, in this neighborhood, if it's sunny, there is during a couple of hours too much production. And here we have a nice visualization. 3 hours, 100,000 watt surplus in production. We could have charged more than 20 EVs, or you can take 150 CO2 neutral showers. And this electricity comes at the moment that electricity is not really needed, and it's also very cheap. So if we can put that in the available EVs, and about a third of the EVs is always present. People are working, but people are working not every day at the office. Home working is more and more popular. People are working part-time. People go with the bike. So about a third of these batteries are present there, and do not load them at the undesired hours, load them at the desired hours, and make this also something which fits into a business case. Now, this is a brief overview. We do know very much here on the right what happens with the sun. We do know what the EVs, we have a big database where all individual EV sessions are being registered. So start moment, end moment, charge moment, stop charge moment, and that gives us a lot of insight. This data control is super important. And now with the European project that we're doing, this Flex City, we have already installed 80 sub-meters in the houses of the inhabitants, allowing us online real time to see how their energy usage is going, compare that with the energy usage of the transformation house, and they receive advice on how to behave. And that can be structurally, and it can also be by a push message. And the idea is to show that with the participation of about 30%, we can really make a difference. And the nice thing is that we had 2 sessions in the neighborhood, and 25% already formally have subscribed with a consent form that we can measure their energy data in order to demonstrate the value of this system. Now,
Well, I have to ask you to cut it a bit short because we need to close in a few minutes, and I wanted to leave the room for some questions. So
okay.
very briefly.
Okay. Now I will then skip this one. Here we show how people can do peer-to-peer, and we also have company supporting that. So if you give your energy to the EV of your neighbor, we will do a special fair pricing on that. It is quite complex. We need to go to make a special entity. You need the energy management platform. You need an official national measuring platform, and the organization side is far more complex than the technical side. The main beneficiary of this all is the DSO. The DSO now starts to say that they want to contribute, and we're in a discussion how to contribute that and how to make this more and more common in order to make it scalable and highly replicable. That was my main story. Thank you very much, Andrés.
Thank you, Hugo. Very interesting story indeed. We have run over time significantly, but I didn't want to interrupt this very interesting presentations that we were having from different speakers. But I will invite everybody on the stage. We have a few minutes left, and I will start with Baerte, and just very briefly to end this panel, this presentation. What can member states, or what can the Netherlands in your case do to facilitate Elaad's proposition? What is your one message that you would like to pass along?
Yeah, I mentioned the regulatory barriers. So be keen on monetizing, regulate the market, but don't over-regulate it, because there has to be, we are discovering day by day new things, and if you over-regulate at this moment, that will kill also innovation. But you have to protect consumers, for example, for vertical integrated producers, so that is a vehicle works only with a specific energy contract and a specific charger, but on standards and protocols, on taxation, there can be things set. Taxation, no double taxation. It's a no-brainer. You also mentioned it, Andrés. Solve it as soon as possible. That is a thing for the Netherlands, but also other European entities. Or, sorry, it was Jack that mentioned that. Sorry.
Thank you. Yes, indeed. Regulate, but don't overdo it. Do not put too many barriers. Csaba, from your side, you talked a lot about financing. You took a different perspective from, looked at the issue from a different perspective. Are the challenges that you will be facing in the next 3 to 5 years, or that you see that we could face in the next 3 to 5 years, different? Or what do you think will be the bigger challenge to implement a model like this servitization of batteries?
From our standpoint, it's very simple. The money is there. I mean, the investors, there are more investors coming into this space. It is actually the products which are missing. So if we don't get scale, if we don't get enough batteries to be financed, or EVs to be financed, then the investors are going to get uninterested by the space. And I think that is the biggest risk.
Thank you, Csaba. And Jack, from your side, you gave us this perspective of BeNeLux, but of course your study looked at whole of Europe. Is the BeNeLux region a region where we can learn of the rest of Europe, or the other way around? Can the BeNeLux region look at some other region or another EU country where they could learn something from?
I think my first response to that is that within the BeNeLux region, there is variation that we found within the kind of regulatory framework and how mature the framework is in terms of promoting V2X. So I think in general, Netherlands is performing slightly better than Belgium is in terms of creating an environment that promotes V2X. I think in comparison to the rest of Europe, I think Netherlands scores reasonably highly, and I think that's around kind of access to a diverse range of revenue streams, and also kind of EV charging infrastructure and fleet requirements. So definitely lots to be learned from some parts of the BeNeLux region.
Thank you, Jack. And Hugo, to end with you very briefly, I mean, the DSO is going to play a significant role based on what you highlighted. What would you ask DSOs? Not only you're connecting DSO in the city of Amsterdam, but in general, DSOs across Europe, to be able to take on this challenge that many other cities will probably face.
DSOs, in my opinion, should be as open as possible with their data. Of course, make it privacy good, guarantee the privacy, because we have smart meters, and we are now installing extra smart sub-meters in our smart meters because of legislation, because of privacy laws. It's really unnecessary and not very intelligent. And another thing is that the market and the energy grid are no longer able to cooperate as they were. If we in the Netherlands have a lot of wind and we want all to charge our car with negative energy prices, the veins of our electricity system explodes. You get a heart, like happens in the veins of your brain, like boom. We can't do that anymore. So we need to take that into account. So if there is a lot of demand, you need to have a kind of flexible grid price as well, not only energy price. Otherwise, it's not going to run.
Exactly. And behind of that is all regulation, cost reflective network tariffs, already something that the original market design from 2019 was covering, but it's not been really implemented just yet. But with that, I want to close this webinar. We're already a couple of minutes over time. I don't want to close it before saying or sending my gratitude to all the speakers. Thanks a lot for your very engaging presentations. I know we couldn't answer all the questions, but you can reach out to me or to the speakers, and they will be more than happy to answer them. Please also, if you have a minute of time, go into the survey and try to answer it to see what your understanding of electric vehicles and V2X or bidirectional charging is. And I just want to close then this webinar. Two very important messages. The money is there, as Csaba was saying. The interest is there. We really need to scale this. And the other message is that the challenges that the Netherlands and Amsterdam are facing right now are something to learn from for other municipalities and other countries, because we are also going to see the same thing happening elsewhere: increased renewable production, increased electrification, it will create significant congestions everywhere. So let's take this opportunity with these projects, with the learnings from these projects, to try to implement these solutions, these forward-looking solutions like Csaba was proposing, and to be able to overcome this hurdle. Thank you, everybody. Thank you for joining us. We will follow up. We have still 2 more webinars on this series. You will hear very soon from us. The next one will be in April, and we will be happy to welcome you back. Thank you, and have a nice day.
You too, Andrés.